While the entire world was distracted by the Tesla bot's clumsy dance and the Cybertruck's controversies, Elon Musk may have quietly taken the boldest step since the start of the electric vehicle revolution. No conference, no spotlight, no fireworks, just a leak here, a patent there, and rumors coming straight from the assembly lines reveal what could be the true end of lithium batteries at Tesla. The name of the replacement? Aluminum-ion battery. It may seem like just another innovation in a sea of technological promises, but this one carries implications that could change the entire game. And quickly. While everyone else focused on design, Tesla was redesigning the heart of the electric car, the battery. The difference begins with the chemistry. While lithium batteries use ions with a single positive charge, Li+, aluminum works with trivalent ions, Al3+. This means that with each ion transported, the aluminum moves 3 times more electrical charge. In other words, more energy circulating in less time and space. It's as if Tesla swapped a tractor for a high-speed train to move energy within the battery. This detail, almost invisible to the average consumer, represents a silent but brutal leap in performance. And precisely because it's so technical and silent, it may be going unnoticed by the public. But anyone who understands electrical engineering even a little quickly realizes the impact. A battery that uses aluminum instead of lithium has the theoretical potential to deliver up to 10 times more capacity per gram at the anode. If you're trying to add more range to a compact car like the Model 2, this is music to your ears. After all, every cubic centimeter saved means more space for comfort, safety, or even design. And unlike the exaggerated promises flooding the automotive industry, this evolution is being tested, refined, and discreetly integrated into Tesla's gears. But it's not just a matter of performance. Aluminum is everywhere. In the earth, on supermarket shelves, and now, perhaps under the hood of your future car. It's the third most abundant element in the Earth's crust, while lithium must be excavated from geographically strategic and geopolitically sensitive mines. The result? Less dependence on unstable regions and morally questionable extractive practices. With aluminum, the production chain not only becomes more ethical, but also much cheaper. And in an industry where every penny counts, this changes everything. Just to give you an idea, cobalt, one of the most expensive and controversial components in lithium batteries, once cost over $80,000 per ton. Aluminum, meanwhile, hovers around $2,200. Not to mention that it's recyclable with only 5% of the energy required for raw extraction. This massive difference in cost and sustainability could herald the dawn of a new era, truly affordable electric cars. And it's not just an environmental or ethical issue, it's a strategic market move that no competitor can ignore. Another rarely mentioned advantage is the chemical stability of this new technology. The aluminum-ion battery can operate in temperatures ranging from 50 degrees C to 85 degrees C without risk of explosion or loss of performance. This means that, whether facing the cold of Canada or the heat of the Brazilian hinterland, the car remains reliable. It's no exaggeration to say that, with this battery, Tesla is developing a new type of global mobility, resilient, democratic, and adaptable to virtually any climate scenario. And of course, there's the issue of quiet innovation behind all this. Tesla doesn't usually announce revolutions at packed conferences. Elon Musk prefers to surprise with results. While competitors are still betting on incremental versions of lithium batteries, the company is already testing behind the scenes a change that could rewrite the entire formula for the modern electric car. And if the first model to receive this battery is indeed the Model 2, as the leaks indicate, the impact will be twofold: technological and economic. The curious thing is that this game-changer is being engineered without fanfare. While many analysts debate design and autonomy based on outdated parameters, Tesla seems to have decided that the future will no longer be driven by lithium-ion. It will be driven by something lighter, more powerful, and infinitely more scalable. And if that happens, anyone still betting on lithium may simply be left behind. The race has changed, but few have realized that the car has already turned the corner. The biggest revolution in Tesla's batteries may not just be in the chemistry, but in what it allows you to do in the real world. Safety, ultra-fast charging, and durability that defies everything we've ever known. It's as if someone decided it was time to stop treating batteries as fragile, finite components and start treating them as the resilient heart of a future car. And the most surprising thing? All of this is already happening behind the scenes. The aluminum-ion battery isn't just promising, it's delivering results in the laboratory that until recently seemed like science fiction. Let's start with safety. One of the biggest concerns with lithium batteries has always been the risk of overheating, explosion, and fire. Well, aluminum batteries use an ionic liquid-based electrolyte, which is non-volatile and thermally stable up to 200 degrees C. This means that even in extreme situations, such as collisions or short circuits, the risk of fire is virtually zero. Tests conducted by universities like Stanford have proven that these batteries can be punctured, crushed, or heated, and still won't ignite. In a world where every EV explosion makes headlines, this is a game-changer. But while the safety is impressive, the recharge time is jaw-dropping. Instead of waiting 30 or 40 minutes to reach 80% charge, as happens with lithium batteries even in the most powerful superchargers, aluminum prototypes are achieving full recharges in under 3 minutes. That's right, less time than you spend waiting for your coffee to brew. And even if the final models for production vehicles don't reach this extreme, estimates are that they will be between 350 and 500 kilowatt, which would already reduce recharge time by more than 80%. This makes charging the car as fast as filling up a tank of gas. And it doesn't stop there. The durability of this new battery redefines the concept of useful life. While lithium batteries begin to degrade after around $1,000 to 3,000 cycles, aluminum-ion batteries can exceed 12,000 cycles without a noticeable loss of performance. In simple terms, this represents about 2.5 million kilometers driven. Imagine a car driving 200 kilometers a day, every day, for over 30 years, and the battery is still there, strong and sound. This longevity opens doors not only for cars, but also for electric aircraft, commercial fleets, and even stationary energy solutions. In extreme environments, these batteries also demonstrate significant advantages. Their thermal stability allows them to operate in temperatures ranging from 50 degrees C to 85 degrees C without loss of efficiency or risk of failure. This eliminates geographical limitations and ensures that the same car can safely operate in the icy regions of northern Canada or the scorching heat of Australian deserts. This operational versatility dramatically expands the market for electric vehicles, making them more reliable and universal. Beyond performance and safety, there's a question of emotional trust that few people talk about. Many people still avoid buying electric cars for fear of being left stranded, unable to recharge, or the battery dying too soon. A battery that doesn't catch fire, charges in minutes, and lasts decades has the potential to eliminate all these fears in one fell swoop. And this is as powerful as any technical advancement. After all, more than convincing engineers, it's necessary to win over the general public, and that's achieved through trust. In the world of electric aviation and heavy-duty transportation, durability also represents a profound change. Today, many in these sectors avoid batteries precisely because of their accelerated wear. With such a long life cycle, companies could invest in electric fleets that last longer, require less maintenance, and drastically reduce total operating costs. In short, the impact goes beyond the automotive sector and could affect the entire global logistics chain. Even the concept of maintenance is beginning to change. If the battery lasts so long and withstands extreme conditions without failure, warranty plans, vehicle resale value, and trust in after-sales service completely transform. Buying an electric car is no longer a risky gamble and becomes a rational, safe, and financially smarter decision. This paves the way for mass adoption, which until now seemed a distant goal. What Tesla is developing, therefore, isn't just a faster or safer battery. It's a component that addresses the three main objections people still have about electric cars: the fear of catching fire, the waiting time for recharging, and premature wear. If it can fit all of this into the Model 2, the barrier between the present and the future of mobility will simply disappear. Behind the scenes at Tesla, a quiet revolution is taking shape, with features that go far beyond innovative chemistry. What truly sets the company's aluminum-ion battery apart isn't just that it's safer, faster, or more durable. It's the unique set of technologies that transform this cell into a nearly living organism, capable of adapting, healing, and even changing the way a car is designed from the inside. If anyone still thinks batteries are just static energy blocks, they haven't seen what's being prepared for the Model 2. One of the most impressive advancements is the introduction of self-healing electrodes. That's right, the battery literally repairs itself. Instead of suffering from internal microcracks with each charge and discharge cycle, as happens with traditional batteries, Tesla's electrodes use silicon-aluminum hybrids capable of atomic realignment. This allows microscopic cracks to close automatically, preserving the cell's structure. This technology, which sounds like something out of a science fiction movie, maintains up to 95% of its original capacity even after 5,000 deep cycles. This type of chemical resilience represents a game-changer in battery engineering. Typically, over time, cell wear forces manufacturers to reduce vehicle power to preserve range or safety. With active self-regeneration, this is no longer necessary. The battery adapts, recovers, and maintains stable performance for over a decade. This directly impacts the user experience, who now has a car that delivers the same performance in year 10 as it did in year 1, something unthinkable in today's market. Another aspect that puts Tesla ahead is the structural format of the new cells. Instead of traditional cylindrical formats, such as the 2170 or 4680 models, the company is adopting the so-called soft pack. These cells are malleable, thin, and flexible, with a laminated multi-layer film casing. No metal housings. This reduces weight and thickness and allows the batteries to be molded around the car's structures. It's already possible to imagine batteries being embedded in the doors, seats, or even the roof of the vehicle, taking advantage of every nook and cranny of the interior design. And the most fascinating thing is that this structural flexibility doesn't compromise safety or efficiency. Quite the opposite. Soft packs offer up to 15% more usable internal volume, precisely by eliminating the empty spaces between cylindrical cells. And, combined with low-pressure liquid electrolytes and polymer seals, they can even be slightly bent without any loss of performance. This paves the way for lighter, more spacious, and more aerodynamic car designs, without the rigid limits imposed by conventional modules. This design freedom also impacts the vehicle's center of gravity and structural safety. By distributing the cells more evenly, engineers can lower the center of mass, reinforce impact zones, and expand the usable cabin area. In compact cars like the Model 2, where every inch matters, this represents a huge advantage in ergonomics, comfort, and efficiency. The battery is no longer a dead weight, but becomes an integral part of the vehicle's architecture. And when the life cycle finally ends, the recycling process developed by Tesla promises to be as innovative as the battery itself. Forget traditional methods that use strong acids or thousands of degrees of heat. The new system is based on dry mechanical separation, using vibration, magnetic fields, and pressure to recover the materials. The result? No toxic waste, up to 40% lower costs, and the ability to scale this process globally. The battery, therefore, is born and reborn within a closed and sustainable system. This full-cycle approach from production to reuse, strengthens Tesla's position not only as a vehicle manufacturer, but also as an energy powerhouse. With less reliance on hazardous materials, lighter weight, greater efficiency, and easier recycling, the company turns the battery into a competitive advantage across the board. While competitors are still debating which cell to choose, Tesla is already designing its car around the next generation of energy. With all this, the battery ceases to be an expensive accessory and becomes the energetic brain of a new type of vehicle. A vehicle that can last decades, adapt over time, and completely redefines what we expect from an electric car. It's no longer just a question of power or range. Now, the battery thinks along with the car. With the energy transition accelerating worldwide, relying on unstable supply chains has become a risk no company can afford to take. And that's precisely where one of Tesla's most strategic moves comes in, with its new aluminum-ion battery. It breaks, once and for all, the dependence on lithium, and, with it, China's direct influence over this market. This isn't just about chemistry. It's about industrial sovereignty. It's about freedom of maneuver in one of the most competitive sectors on the planet. Lithium, despite being considered the new oil of the electric age, has a supply chain that revolves around a few players. The biggest of these, of course, is China. Today, even when lithium is mined in countries like Chile or Australia, it is often refined in China before reaching factories. This means that any geopolitical tension or trade dispute could halt all battery production. And with demand exploding, prices are on a constant roller coaster, difficult to predict and even more difficult to control. With aluminum, the scenario is completely different. It's one of the most abundant metals on the planet, mined in over 40 countries. The three largest producers, China, India, and Australia, have extremely high and, more importantly, diversified supply capacity. This drastically reduces the risks of concentration and shortages. Furthermore, aluminum can be recycled virtually infinitely, using only 5% of the energy used in its original production. The combination of availability, recyclability, and geographic distribution makes this metal a true geopolitical asset. In the United States, this change has even more profound implications. With the signing of the Inflation Reduction Act, the U.S. government began offering incentives of up to $7,500 per electric vehicle manufactured with materials that don't depend on countries considered strategic adversaries. In other words, by eliminating lithium and rare earth metals from its equation, Tesla now qualifies for the full package of tax incentives. And that's no small feat. Billions in competitive advantages accumulated over the years. The new battery also places the company in a privileged position to control its own production chain, without intermediaries. With aluminum mined and processed in several U.S. states and through reliable trading partners, Tesla can vertically integrate its supply chain, reduce logistics costs, and react more quickly to market changes. This is an operational independence that manufacturers still dependent on lithium, such as GM, Hyundai, and even BYD, cannot replicate with the same agility. This freedom also paves the way for more advantageous negotiations with suppliers and governments. Imagine being able to secure long-term contracts with predictable prices, without fear of sanctions, embargoes, or tariff disputes. Tesla ceases to be just a buyer of inputs and becomes a strategic manager of raw materials. And this completely changes the game when it comes to global competitiveness. Because having the best product isn't enough. You also need to ensure it can be produced at scale. And speaking of scale, aluminum offers another valuable benefit: predictability. While the prices of lithium, cobalt, and nickel rise and fall like a roller coaster, aluminum maintains much greater stability in the global market. This allows Tesla to project long-term costs, plan factories more efficiently, and avoid sudden price adjustments for the end consumer.